Hello guys, welcome to my channel. My name is Abhishek and in today's video we'll discuss pointers and 2D arrays. Okay, in the previous video we have seen how the actual array gets converted into its pointer notation by the compiler during compilation. In today's video, first of all we'll see what are 2D arrays, a basic introduction to it, and then we'll see how the C compiler will internally convert this notation into its pointer notation. Okay, so 2D arrays are declared using this syntax. Okay, this is a declaration of 2D array, and this declaration we can think that when we, let's say first of all, when we say int a and 5, what does this mean is we are simply declaring a variable a which will contain 5 elements. Okay, so a will contain 5 elements, 1 2 3 4 and 5. This is a. Now when we say int a 5 and 2, what does this mean is it means that we have 5 one-dimensional arrays of 2 elements each. We can understand it by using this diagram, a of 5 2, that is we will have 5 1D arrays which will have each one-dimensional array will have 2 elements each. So we have 5 1D arrays 1 2 3 4 5, and each one-dimensional array has 2 elements each. Okay, 2 elements each. But in the memory no block is created like this. The actual memory is continuous, so that's why in the memory the value will be in this format only. We will get a continuous memory block since it is an array, so that's why we'll get this. So we have discussed, now I have written this only here. This declaration can be thought of as setting up one-dimensional array of 5 elements, each of which has a 1D array of 2 elements long. Okay, this thing only. And now when I had a 1D array, suppose this array only int a5, when I used to say and a of 0, that means the base address of this array. Okay, the base address, suppose the base address of this array is 100, so it means 100, and I can write it as simply a. When I write simply a, it also means the same. So address of a of 0 is equivalent to the variable a, which is the array name. Okay, it also represents the base address. So in a similar manner, when we have int a of 5 2, if we will write a of 0, it will print the address of first 0th one-dimensional array. Why is it so? Because since when we write a, it represents the base address of this array, and when we write a of 0, it will represent the first, that is, you can call it 0th or the first. I'm calling it 0 since it is the 0th index here. So a of 0 will represent the first 0th one-dimensional array, since there are 5 1D arrays. So a of 0 will represent this, a of 1 will represent this. So a of 0 will represent the base address of this thing, and a of 1 will represent the base address of this, and so on. So that's why you can say that a of 0 is equal to 4001. I have made this diagram to understand this thing very clearly. So now let's see, if we have a of 5 2, that is we will have 5 into 2, that is 10 elements. So we have taken 10 elements. Here we have 5 one-dimensional arrays of 2 elements each. Okay, so these are the values I have stored in them, 10 11 12 and so on. So when I'll say a of 0, it will refer to the first 0th one-dimensional array. This is the 0th one-dimensional array. This is the first 1D array. This is the second 1D array. This is the third one-dimensional array, and this is the fourth one. Okay, I'm using the subscript from 0, that's why it's 0 1 2 3 4. Okay, so these are the 5 one-dimensional arrays, and when I'll say a of 0, this will mean the address of this. So a of 0 will print the address of it, that is 4 was 001. Okay, this will be 4001. And similarly, when I'll say printf percentage u a of 1, this will print the address of the first 1D array. So address of the first 1D array here is 4009. Okay, this is the 0th one-dimensional array, this is the first one-dimensional array till here. Okay, from here to here. So that's why it will print the address of this 4009. Similarly, if I'll say printf percentage u a of 4, it will print the base address of the fourth one-dimensional array. So this is the 0th 1D array, first, second, third and fourth. So it will print the address 4033. Okay, so output of this will be 4033. Okay, and this is just the explanation of what we have learned so far. 2D array is just a collection of a number of one-dimensional arrays placed one after another. Okay, so the memory they get is continuous always. It is not the case that they will be represented in the memory like this. This is just for our basic understanding. that we have 5 one-dimensional arrays of 2 elements each. Okay. Now let's see a program for the concept we have learned so far. We have defined a 2D array as 5, 2. We have defined it here. Okay. If we will not write these curly braces also, then also the array will get initialized. This is done by the compiler itself. We will give just the size here. Okay. And we are taking two variables, I and j. I is for loop variable. Okay. J is not used there actually, so need not write this. So what we are doing is we have 5 one-dimensional arrays. So I am running root from 0 to 5, and simply I am printing the address of the one-dimensional arrays. I am saying s of I. S of I will print the addresses. Okay, the things which I have already discussed. From that diagram, if we'll see, the output will be something like this. We'll say address of 0th 1D array is 401, first 1D array is this, and so on. Okay, according to our diagram. Okay, our diagram was this now. First 1D array was 4001, second was 4009, then 4017. So 4001, 4009, 4017, and so on. Okay, so this was a simple program. And now let's understand the further concept. Now if I will write simply s, so it will mean that it is the base address of the two-dimensional array. Okay, in this similar manner, like if I have a integer array int a of 5, if I'll write and a of 0, or I will write a, these both statements are similar. In the same manner, if I'll write simply s, so it will point to the base address of the two-dimensional array. So s is treated as a pointer to the 0th element of the 2D array. Okay, so when we'll say simply s, so s will point to this base address of this array, 2D array. Okay, s will point here, so s will be 4001, and since it is pointing to the 0th element, so what is the 0th element here? It is itself a 1D array of 2 elements each. So this is the whole 0th element we are talking about, and each element is having 2 variables each. Okay, 5 1D arrays of 2 variables, or we can say 5 one-dimensional arrays of 2 elements each. Okay, so s will point to this location, and I can also write s as s plus 0. So s plus 0 is the base address of the 2D array, we can say. Okay, since s is pointing here, so I can also write s plus 0. So this is the 4001, and when I'll say star s plus 0, okay, it is equivalent to the notation s of 0. We have learned this in the previous lesson. If you don't know this, I'll give the link in the description, you can see that. So this is equivalent to s of 0, and what is s of 0 in this case? S of 0 is representing the first 0th 1D array. So 0th 1D array is this. Okay, so we can write this or this, both these notations are same, and s of 0 is what? 4001, so it will be equivalent to 4001. Okay, so this is the 4001, this is the address here. So should we give 0th element, because 0th element of 2D array is itself a 1D array of having 2 elements each. Okay, this is what I have told here. Now similarly, if I'll say s of 1 in this 2-dimensional array, what it means is, it means s of 1 is equivalent to star of s plus 1, and this is the first one-dimensional array which is having 2 elements. So this is the 0th 1D array, this is the first 1D array. So s will now point to this when we'll say s of 1. S of 1 means this whole part is s of 1. Okay, this is s of 2. So star of s plus 1 or star s of 1 are same, and this is representing the address 4009. Okay, this is what I have written here. And similarly, when I'll say s plus 2, this means s of 2. And what is s of 2? That is second 1D array of 2 elements each. So this is the second one-dimensional array. This is 0th and 1D array, first 1D array, second 1D array. So second 1D array, and when we'll say s of 2, so the address it will store is 4017, and this notation is equivalent to star of s plus 2. Okay, and if I'll say s of 3, that will be equivalent to star of s plus 3, and it will hold the address what? 23, this 4025. And similarly, when I'll say s of 4, it will have the address 4033. Okay, so this was the concept. Now guys, in general we can say that s of I, or asterisk symbol you can say, or star of s plus I would give the base address of the ith one-dimensional array. Okay, now by using s of I, what we have done is we have been able to reach this base address till this time we have just reached the base address. Now we need to access these elements as well. Okay, so now we have been able to reach the individual row. Now we need to refer to the individual elements of the row. This is what I have told here. Now if I want to refer the element s of 2 of 1 using pointers, okay, so how will we do that? Now we'll understand this thing. We already know that s of 2 means the second one-dimensional array base address. So this is the 0th 1D array, first and the second. So s of 2 will mean 4017. This is the address. Okay, so I know s of 2 will give me the address of second one-dimensional array, that is 4017 here. And when we'll say s of 2 plus 1, what will happen is this will take, when we'll say s of 2, our pointer is pointing to this location initially, and when I'll say s of 2 plus 1, what it will happen is this pointer will start pointing to the next location of the same type. So s of 2 plus 1 will give me the address 4021, which is what is 4021? This one address. So initially when we'll say s of 2, the pointer will point to this location, okay, this one. And when we'll say s of 2 plus 1, what will happen is the pointer will start pointing to the next location of same type. So the pointer will now start pointing to this location when we'll say s of 2 plus 1. Okay, so s will come here. When we'll say s of 2 plus 1, pointer s will come here. Okay, and the value at this address, we need to fetch this value. We need to print 15, suppose. Okay, so how can we fetch this value? We'll simply use the value at address operator, and we'll say s of 2 plus 1. Okay, and from the previous video we have learned that s of 2 can also be written as asterisk symbol of s plus 2 or star of s plus 2. So therefore I can substitute this value here. I'll get this thing. Okay, star s of 2 can be written as star s plus 2. I have just substituted this here, and it becomes star of this value I have substituted here, and then plus 1. Okay, so this is the representation of two-dimensional array. This is the representation of s of 2 of 1. Okay, similarly, if you want to represent s of 3 of 2, this value in the array, you'll simply say star of s plus this 3 and plus 2. Okay, so this value will be equivalent to s of 3 of 2. Okay, so in general we can say that all these expressions refer to the same element. S of 2 of 1 can also be written as star of s of 2 plus 1, and this expression can also be written as star s of plus 2 or plus 1. Okay, we have just substituted the value of s of 2 with this value. So all these things means the same. In the next video, guys, we'll see the example for this explanation, that how the values are getting printed. Until the time, take care. Bye bye. If you like this video, click on thumbs up button, do subscribe to my channel, guys, and share this video as much as you can. Thank you. Take care. Bye bye.